this graph that's going to show up here, they're going to graph it in just the XY plane for us, I think. Oh, I just cut on the recorder. I didn't cut on the... There we go. Okay. It's going to graph us. It's graphing us in the XY plane. It's also graphing it over here in the like XYZ plane. Because you can graph things 3D. Obviously, you can't do it on flat paper. But you can graph things in an X, Y, and Z plane. In fact, if you take Calc 3, that is what Calc 3 is. It's 3D calculus. You're doing some of the stuff you already learned how to do in Calc 1 and 2, but you're doing it with 3 variables. So you got an X, Y, and a Z for your functions. It's yeah, it's like in it. It's when it rotates, you can see it better. Let me just let it. Okay, there's your axis there. So you got like your Y is here and your X is here. All right, then if we rotate it around the oh gosh, they put the X-axis vertical and the Y-axis horizontal in that. Not like that. But it's still, you can still get the picture of what's happening. It makes this really cool, like, pointy basket shape. I always think these would make really cool hats. Look at this next one. It would make a good hat as well. If you rotate this around the Y-axis, here we go. Rotate, so this would be just a really good like beach hat right here, or sombrero for that. So this is what we're going to do for our, this is what we're going to do for when we get to it for our, huh? Oh, look, there you are. Yeah. Yeah. This is because my computer is signed in underneath my name, and after school, Henry and Jace and some of them come and get my computer and watch YouTube. So my YouTube is a mixture of math videos and Nerf Wars. You'll notice like it's all that I have. It's either math videos or Lego figures and Nerf Wars. And one broadcast. Yeah. All right. Back to our notes. I think so. You can watch it in the we'll watch it in the EHS time. Okay. So the formula for these, if you're rotating around a horizontal axis, okay, today that is only going to be the x-axis. We will learn how to do other axes, but today it's only the x-axis. If you're rotating around a horizontal axis, your formula is going to be pi, the integral from a to b of capital R of x squared. This capital R of x is going to be your radius of that revolution. And if you do this around a vertical axis, then it's the same formula except for what's different this time. Everything's in terms of y. Okay. So much like if our cross sections were perpendicular to the x-axis, we had to use x's. If our cross sections were perpendicular to the y-axis, we had to use y's. You're going to have a horizontal axis will give you x's here, vertical axis will give you y's. Yes.
Would the radius just be like the height of it before we rotate?
Where's my baby bottle one? Somebody's still got that. So for example, for this, your radius is like a sliver here, right? That's your radius, because when you rotate it, it would be like the radius of that circle that's created right there. Let's do a problem. Okay, so we are going to find the volume of the solid formed by revolving the region bounded by the graph of f of x equals sine x, and I should say and the x-axis from 0 to pi. about the x-axis. This looks a little funny and does not look like pi because of my scale on this. I should have probably went and made that scale a little better. But, because that doesn't even look like sine at all, does it? It's supposed to look a little funny. That looks really funny. I'm going to fix that. Let's fix this. This does not look good. Let's go to Desmos real quick. Y equals sine x. 0 less than x less than yeah, I don't even know what exactly it was I did there to get it to look so football shaped instead of taller like this. Let's see. Let's zoom in. Yeah, I think I have the wrong graph, honestly. That doesn't look right at all. We can still do it. We'll be okay. Don't mess up my bottle. Don't mess that up. Okay. All right, let me save this. That's a better. Okay. So, if we take this and rotate it, what's our 3D figure going to kind of look like? It's going to be sort of football shape, but it's probably going to be like kind of too fat in the middle and too pointy on the ends. But it's going to be similar to a football shape, right? So what we're doing whenever we do this is we're taking a slice somewhere, and we're rotating around the vertical axis. So we're taking this slice and we're rotating it around the x-axis there, and it will create a circle. And then we're taking every other point next to it and we're rotating around the x-axis, and you'll have all these circles next to each other. So this piece right here, that is your capital R of x. Okay, that's your radius. So R of x, just like we were doing with our cross sections, it is going to be the top function minus the bottom function if you're in terms of x, right? So the top function is the square root of sine x. The bottom function, what is that? It's 0. So you can put 0 if you want, but that's unnecessary. So it's just the square root of sine x for your radius. Okay, so it's going to create a circle whenever you rotate it. So all of these revolution problems are going to involve the area of a circle. So the formula for the area of a circle is pi times the radius squared. So we're going to be doing pi times r of x squared, right? So we'll do pi square root of sine x squared. Okay, that would give us the area of just that single circle, but we want to add all of the circles that will be created together, so I'll need to integrate, right? And what should my limits be? 0 to pi. Right. Now, in the formula that you have over there beside it, it has the pi on the outside. It's a little easier if you just leave your pi on the outside to calculate anyway. And what is the square root of sine of x squared? Just sine of x. And I was lazy right there and forgot my dx. So this one's a pretty easy one to do by hand. We're going to do this one by hand. What do we get when we integrate sine? Negative cosine. So we'll have negative cosine of x. We will evaluate that from 0 to pi. We will have a pi out front. And so let's just keep the pi out front. We got negative cosine of pi minus negative cosine. So that's going to be plus cosine of 0. And so what is cosine of pi? -1. So that's going to give us a +1 when we have that -1. And what's cosine of 0? 1. And so what are we going to get for our answer? 2 pi will be our answer. So the volume of that piece would be 2 pi units cubed, whatever your units are. Something like this, they'll definitely give you without a calculator. That one didn't even take us that long to do, right? A lot of the others, they're probably going to give you a calculator or just ask you to set it up. Okay, questions so far? It's kind of similar to what we were doing with the cross sections, but your formula is always a circle, a whole circle, not a semicircle, and your radius is just going to be that slice there. Usually today we're going to have it's probably going to hit the axis, right? The notes are called the disc method because if you think about that thing that Bo's got there, it makes a bunch of teeny tiny little discs, and when you put them all together, it gives you the volume. We will learn about the washer method on Monday, which is pretty much the same except for all of your discs will have holes in the middle of them. It'll be a figure with a hole in the middle of it. They do because they are on that pole, but imagine that they only did that because for you to take it apart, it has to have some way to keep it together. If they were like magnetic, they wouldn't have had holes in them. They should have made a magnetic, shouldn't they? Be better. Okay. All right, so we are supposed to find the volume of the solid formed by revolving the region bounded by the graph of f of x equals x to the third plus 1 and y equals 0 and x equals 2 around the x-axis. So let's think about what this graph is going to look like. I like to do my horizontal lines and vertical lines first. So I've got y equals 0. What is that? It is our horizontal axis. So x-axis right here. There's that line. I've got x equals 2. That's going to be a vertical line at 2. And then I've got to graph x cubed plus 1. So I'm just going to plug in some numbers for that. Let's see, it did not include the y-axis, so it could be negative numbers here as well. So what do I get if I plug in -1? Let's make us a little table here. If I plug in -1, I'll get 0. So I need to include that point right there because that's where we're going to cross. If I plug in 0, what do I get? 1. If I plug in 1, what do I get? 2. 2. And if I plug in 2, what do I get? Oh gosh, why did I make this scale like that? That's not a good graph either. I need to replace that one, but alright, we should get 9, which is going to be like way up here, right? So our cubic looks like this. It's probably going to cross way up there because my graph is bad, but you can get the idea here. I don't know why I didn't go up further on that. So we're looking at this area right here, and we're going to spin it around the x-axis. What kind of shape are we going to get? Yeah, kind of like a mound. Yeah, it's going to be sideways, right? But it's going to be like, sort of like a mound, or it could be a hat kind of, but it's going to have a really weird bill sort of thing there. And considering that I didn't get, if nine's probably actually like way up here. It's going to be a really wide hat. This is like if you're serious about the sun right here. Yeah. Well, no, I think you are rotating around the wrong axis. If you rotate this way, it'll be more of a Hershey Kiss shape. If you rotate this way, it's going to be a lot more curved on the top. It'll be a little less, yeah. I don't know about Almond Joy. I'm not sure about that one.
It's going to be a circular almond.
I think you'd have to cross sections for almond joy when he brings them in. And
Jeremy, do you like almond joy?
I love almond joy.
They're alright.
They're so good. I will pick those out of the Halloween candy every time. All right. Okay. All right. So. All right. Back to work here. We are rotating around the x-axis, so we're taking a vertical slice here. We will be rotating that around the x-axis like this. So this part right here is our capital R of x. There's a reason I'm using a capital that we'll see on Monday. Right now it doesn't really matter, but on Monday we'll see why it matters. So that is just going to be the top of that, which is our cubic function. So that's x cubed plus 1 minus the bottom. But what is the bottom for this one? Just 0, right? So I'm not even going to put it this time. So that means we'll be doing, we will be doing the area of a circle, which will be pi times x cubed plus 1 squared. And we will need to integrate that. Our volume will equal, we'll integrate it. What should my limits be? -1 to 2. We're in terms of x, so we're looking at the x-axis. -1 to 2. If it was around the y, we'd use 0 to 9. Okay, and so it'll be pi x cubed plus 1 squared. I think we can do this one without the calculator. We'll have pi -1 to 2 x to the 6th. Actually, let's not. X to the 6th plus 2x cubed. We'll do it without a calculator, but we'll pretend like it's a free response. How about that? So we'll have pi. We got to integrate. So we'll have x to the 7th and a 1/7 out here. Plus, we'll get x to the 4th, and that'll give us a 1/2 here, and plus x. And we'll evaluate that from -1 to 2. And so let's pretend like this is a free response and that we don't need it for anything else. We would do 1/7 times 2. Oh, yeah, we're definitely not doing this one by hand any further than this right here. We do not have time for that. All right, and we're going to pretend it's FRQ, and we're just going to leave our answer right here. That will simplify, but we are not going to go any further. What I'd like for you to do on your homework is make sure it's set up and integrate it. But if you want to use your calculator to do that, that's okay. So you'll have to set them up, but if you want to use your calculator to get that. And like when I say use your calculator, here's what I do. I want you to integrate it by hand just for the practice of integrating. But then like this takes forever to type into the calculator. It would be way quicker just to type this into the calculator, so you can just type that in if you would like. There is okay. Because it's I really need you to be able to set them up correctly. It is good if we can get to the answer, but our textbook gets a little extensive in how you would have to do all that, because this will take a while to simplify. We're okay here? Yep. On this one, you would need to look for where x cubed plus 1 equals. Well, your x equals 2, you're going to plug in a 2 for your x right here, which will give you, actually no. No, you just know this is a vertical line, so it has to stop there. Over here for that y equals 0, I guess you're setting x cubed plus 1 equal to 0 for that. Because those are your two like y equals equations there. But since they give you that vertical line, you just have to know that's where it's going to stop. for that. Typically, if you're rotating around the x-axis, vertical lines are going to be your limits on that if they're given to you. Okay, let's do one around the y-axis. So we're supposed to find the volume of the solid formed by revolving the region bounded by the graph of y equals 2x squared, x equals 0, y equals 8 in the first quadrant around the y-axis. So x equals 0 is our y-axis right here. So we got x equals 0 right there. We need y equals 8. That is a horizontal line here for y equals 8. And then we've got y equals 2x squared. So if we just plug numbers into that, like make a table, 0, 2 times 0 squared is just 0. If we do 2 times 1 squared, we're going to get 1. If we do 2 times 2 squared, we will get, oh wait, no, we won't get 1 here, will we? We'll get 2, because you'll be doing 2 times 1 squared, which will give you 2. And then we'll do 2 times 2 squared. That's going to give us 8. So, and it told us only the first quadrant, so although this goes back up here, we only want to use the first quadrant. And we're rotating this time around the y-axis. So we are taking, what's that? We are taking this section right here and rotating it around the y-axis. So, questions there? So, our radius of each circle this time should be a horizontal slice right there. That would be your R of X, and it's going to get rotated around that axis. So, our capital R of X, oh wait, I really shouldn't even call it R of X. What should I call it? R of Y, because we're in terms of Y. So, let's fix that. R of Y. Okay. Now, here's the problem. Can the R of Y equal 2x squared? No. It's got to be in terms of Y, right? So, I got to take Y equals 2x squared and solve it for the x. So, I will divide by 2. I'll get Y over 2 equals x squared. Then what would I have to do? Square root both sides. So x is going to equal, technically it is plus or minus the square root of y squared. But we're only using half of this parabola. That plus or minus is like the positive and the negative side of the parabola. This is going to be the positive part, so we want to use the positive. So our R of y is going to be the square root of y over 2. And then what's the left side of that? So that is our right side. What's the left side over here? It's just 0, which is happening on all of these because these are disk method. Whenever we get to tomorrow, it will be a little bit different. So what we're going to do is we're going to take this, we're going to do pi times that radius, square root of y over 2, squared, and then we need to integrate that. What should my limits be? 0 to 8. Not 0 to 2. If it was x, we'd use 0 to 2, right? But 0 to 8, because we're getting those from our y-axis, and we're going to put a dy over here on the end. I would pull the pi out front, and y squared, the square root of y over 2 squared is just y over 2, or I'm going to write it like this, 1/2 y dy. So let's do this one by hand. It's a pretty simple one. You will increase your exponent by 1, which will give you y squared. You have to divide out front by 2. What's that going to give you there? Not 1. 1 over 4. Because dividing by 2 is the same as like multiplying by 1/2. Because we're doing 1/2 divided by 2. It'd be like 2 over 1. Dividing fractions, easy as pie. Flip the second, multiply, we'll get 1/4. The pi is still out here. We are evaluating from 0 to 8. This is going to give us pi. And we'll have 1/4 times 8 squared minus 1/4 times 0 squared. And 8 squared is 64. 1/4 of 64 is going to be 16. Is that right? Yeah, that'll be right. 16. So we will get 16 pi as our answer. Okay, I think the rotating problems, especially when they don't have a hole in the middle of them, are a little bit easier because if it is a rotation, you're using area of a circle every time. You don't have to think about the cross section, whether it's a square or a rectangle or a triangle or a semicircle, right? It's a circle every time whenever you're rotating for that. So I think these are a little bit easier than the ones we've done in the last couple sections because you don't have to think about which formula you are using for that. It's still a little tough getting the picture set up and understanding what your radius is for that. So your assignment here is going to be on page 425, 1, 3, 7, 9, 13A, 14B, 25, and 33. That is 8 problems. Use your calculator to help you out to get all the way to the answer on that. I'm mostly concerned with you being able to set those up. Okay. So it will take you forever on some of them if you do them all by hand, but use your calculator once you get your interval set up so that it doesn't take hours to do. Okay. Also, next week, because I do actually have that ready this time for next week. Because we are at the very end. So next week, Monday is just going to be regular class. We'll do 8:11. Tuesday, we're going to do 8:10 and 8:12. That'll finish us up. Those will be our last sections of calculus we got to go over ever. So unless I just forgot something, whenever we get to reviewing, you won't have any more new notes. So Tuesday, we'll be done with new material. Wednesday, we're going to review. Thursday, we're going to do our FRQ quiz on Thursday next week. The reason is that you guys have cap and gown pictures on Friday. And it starts before school, and I'm sure you're going to miss some of this class. You might be back in time where we could have done it Friday, but I'm not sure. So we're going to go ahead and do the quiz on Thursday. And if you make it back to class, we'll just review some more. But I was going to test on Friday. That was my plan, but I can't test on Friday since you guys are probably not going to be here for the full class period. So that is going to mean a Monday test the 22nd. But we need to go on. So not next Monday, but the 22nd, we'll be done with Unit 8. All material will be done, and then we'll start our review for that. Okay. So be ready for the FRQ on Thursday, and then test next Monday for that. All right, questions? You got about 10 minutes, so go ahead and try to get a couple of those done. Maybe even 3. Up there.